This is question number 8 of homework 5 for chapter 5. You would like to have $36,000 in 9 years. To accumulate this amount, you plan to deposit each year an equal sum in the bank, which will earn 6% interest compounded annually. Your first payment will be made at the end of the year. So this immediately tells us that first that this is an annuity because you're gonna make the deposit every year for the same amount, right? And this last sentence here basically tells us it's an ordinary annuity rather than annuity due, because annuity for the annuity due, the first payment actually will be made immediately. So part A, how much must you deposit annually to accumulate this amount? So this is very straightforward, right? This is asking for the annuity payment. So let me use a new worksheet, Excel worksheet as my calculator. And what's convenient to use Excel is that it has many financial functions already built in the software, so where we can just pull out those functions to facilitate the calculations. So in this case, there's a function called PMT, right? That stands for the payment equals PMT and then open. And you can see there are many arguments here. First one is the rate. So that stands for the interest rate, right? Interest rate here is 6%. So we just put that as the interest rate. And NPER stands for the number of annuity payments. So in this case, you will need this for in 9 years. So 9 is the NPER. And then PV, that's the present value of this annuity. But in this case, you can see that the first sentence reads, you would like to have this in 9 years. So this actually should be the future value, right? Future value of the annuity. So that means present value should be 0. And then the future value, it's 36,000. If I just put 36,000 as it is here, and the rule of Excel or financial calculator is that you will give me a negative payment amount, which means that the payment amount and the future value, they will be of the different signs, opposite signs. So if I want to have a positive payment, annuity payment, then I just need to add a negative sign in front of this future value here, and then I can just and then Excel will return a positive annuity payment. And in the other after future value, you can also notice we also have a type here. This means whether it's annuity due or ordinary annuity. And in this case, by default, it's ordinary annuity. And in this case, we know we have ordinary annuities. We don't have to worry about this type here. So now I can just close the function and then press enter. And then this gives me the annuity payment. But before we stop, then we need to go back to check the rounding requirement. Here it says round to the nearest cent. So I guess this is what we have done already, but sometimes depending on your setup, you may have to adjust the cell format to conform to that rounding requirement. So now I can just copy this value back here and get rid of the dollar sign. I don't know whether the comma sign will be acceptable by MyLab. So let me just check. That's good. Okay, so that means the comma sign actually will be accepted by MyLab. So part B, if you decide to make a large lump sum deposit today instead of the annual deposits, how large should this lump sum deposit be? Assume you can earn 6% on this deposit. So rounding requirement, round to the nearest cent, the same as part A. So now instead of having a annuity problem, we actually have only one single cash flow compounding to this $36,000 in 9 years. So in this case, we can just use the present value function, right, PV, to calculate the present value of that future $36,000 sum. So equals PV and then open. So the interest rate again is 6%, right? So and then the NPR, that's the number of years for the compounding. So that's 9. And then the payment, and this payment PMT stands for the annuity payment. But in this case, we don't have any, we don't have an annuity, so this is actually 0. And then the future value will be the same as part A. And again, the rule will also be the same. The reason I add a negative sign in front of this $36,000 is because I want a positive present value. So now I can just press my enter button, and that will give me this present value. So now I can just copy this number back to my lab, and don't forget to get rid of this dollar sign, and then check my answer. So the final part actually is the hardest one. At the end of 6 years, you will receive $8,000 and deposit this in the bank toward your goal of $36,000 at the end of 9 years. In addition to this deposit, how much must you deposit in equal annual deposits to reach your goal? So this the question, what the question is asking is the same as part A. It's asking for the basically annuity payment. But what's different for this part of the question is that um, now we have this sort of a twist, right? By the end of the 6 years, we have some additional money that we can deposit, hence that we also we can receive the interest on that deposit toward our goal of having $36,000 by the end of the 9th year. So from 6 to 9, which means that this $8,000 will compound for 3 years, and then also combined with our annual deposit annuity payment, and then that can combining these two can help us to reach this goal of having $36,000 by the end of the 9 year. So if I draw a chart on this graph, probably that can further help me to understand what might be going on. So this is 0, this is where I stand, and this is, suppose this is 6. So and in between every year we make some payment. I may not have draw this chart very beautifully, but you can understand there are 6 payment here, and then this is 9, right? So our goal is to have $36,000 by the end of the 9th year. And then we know that in addition to the annuity payment, right, every year, including year number 6, right, every year here. But other than, in addition to this annuity payment, we actually also have a additional money, which is $8,000, which we can deposit into this bank. And then that will also start to earn money. So by the end of the 9th year, which means between 6 and 9, we have 3 years to go for the compounding. At the end of the 9th year, the $8,000 will grow to a certain amount. We know that we can calculate this amount based on the future value function, right? $8,000. And this is for only 3 years, remember, because there are only 3 years between 6 and 9. So once we get the future value of this $8,000, we know that our goal is to have $36,000 in total. So that means the future value of the annuity need only to be the difference between this $36,000 and the future value of this $8,000 by compounding 3 years. So then based on the future value of annuity formula, we can sort of figure out this payment. So that's the strategy to tackle this problem. So with that strategy in mind, now let me go back to my Excel sheet and finish this calculation. So the first is to calculate the future value of that $8,000, right? Future value equals future value, and the rate again is 6%. And the MPER, that's 3 years, right? As we said, and because we only have $8,000, there's no annuity payment here. So payment here is 0. And then the present value is $8,000, right? But again, because I want to have a positive future value, so I just want to add a negative sign in front of this present value, and then close my function. So this is the future value of that $8,000 compounded for 3 years. So now this means that our net goal should only be the $36,000 minus this amount, right? So now we know that this net goal basically should be the future value of the annuity. So now we can use the annuity formula to figure out what it should be the annuity payment. So I'm using the payment function equals PMT, and then open that. First, the argument is rate, which is the interest rate, 6%, and MPER, that's 9 again. Starting immediately, we're going to make the annual deposit, right? That's 9 for 9 years. And then PV, again, this is 0 because we don't have any immediate lump sum because we know our goal by the end of the 9th year, right? So the present value here is 0. And future value, that's referring now to the net goal because that's what we ask the annuity payment to fulfill, right? It's no longer the initial $36,000 because the $8,000 we put in the bank by the end of the 6th year will also work toward our goal. So here, the annuity payment only need to meet this net goal. So that's the future value. And again, because I want to get a positive value for the annuity payment, so I just added a negative sign in front of this net goal amount and close that. And now I can just copy this number back to my lab and get rid of this dollar sign. Again, you can see I followed this rounding requirement round to the nearest cent, right? Okay, so that's done for this question.